All right, so if you open up Simulink, there's a couple different ways that you can open up, MATLAB. There's a couple different ways you can open up Simulink. The first way is going to be to go under New and come down to the Simulink area and just hit Simulink Model. But the way that you can also open up a .slx, that'll go ahead and open Simulink right away. The other way is to go ahead and type Simulink into the command window. On the newer versions of Simulink, it opens up this page, and you have the options of blank models and other things like that. So usually you want to start with a blank model, and here you're going to have your Simulink workspace. It's going to start off blank, but this is where we're going to put all of the blocks that we use. If you used LabVIEW before, this is visual programming just like that. I think it's easy to get used to really quick. I'm recording this, so I will answer that question later. I can answer after. So the next thing that you're going to need to open, it's helpful, is you come up here. This is the library browser. If you click that, it'll usually take a second to load, but I've already opened it, during this MATLAB session. So this will open up your Simulink library browser. This contains all of the blocks that you're going to want to use to build your model. Commonly used blocks here under Simulink is going to be almost everything that you need, but things like sinks and sources are also really important for looking for more specific things. So if we go back to our equation that has disappeared, that's really great. Hang on. There we go. I don't know why it did that. So this equation is what we're going to be basically modeling in Simulink. So if we bring it back up, the first thing that I'm going to do is, since I know that I can take my acceleration, integrate that, and get my velocity, and I can integrate my velocity to get my position, the best place to start for this model is going to be in commonly used blocks, the integrator function. And hopefully this doesn't crash on me, but all right. So the integrator block takes in a time varying signal as its input back here, and it outputs the integral of it here. And Simulink works on a time basis, so you don't have to tell it to derive relative to time. Simulink understands that you're trying to take an integral with respect to time or a derivative with respect to time. For this one, the input's going to be our acceleration, x double dot, and the output is going to be our velocity. Come on. All right. Simulink may have just crashed. There we go. So this is going to be our velocity. Let me check my power plan. No, it's on. So this I think is a little self-explanatory, but we integrate our acceleration to get our velocity. And then you can control-click on something. Oh, not that. Control-click, and you can make a copy of something. So if you don't want to go back in here and grab it and drag it in, you can just make a copy. And Simulink tries to connect blocks for you when you insert new ones. And then when we integrate our velocity, we're going to get our displacement. And so these are the three major variables that are actually going to describe the motion of our mass spring damper system. But in order to get in order to get our acceleration, we have to solve the equation that I had up before. In this case, our input is our force, and I'm going to treat our displacement as the output. So what we're going to use for that is a sum block, which is over here, a list of signs. So newer versions of MATLAB give these nice little things here, so I can list plus, 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 and it'll create 3 for me. But if you ever want to alter that, you can double-click on it, and you'll have the list of signs. You can also change it to rectangular, which I prefer a lot. So we can take that, just like most visual programming and stuff, you can expand things. And what we're going to do here is we're going to sum our input force, our damper force, and our spring force, and get our what we're going to get out of that is the total force acting on the body, and then if we divide by our mass, we can find our acceleration. So, in that equation that we had, when we take our velocity and we take our displacement and we calculate a force from that, we want to multiply it by some constant for the system. So there's two ways that you can do this, and I'll show you the one that makes the most sense first, and then the one that is is best practice in Simulink. So for multiplying two things together, you can use a product. If you're going to multiply two things that might be varying in time, this is what you want to use. So if you, for some reason, wanted to multiply your velocity by your displacement, this is what you do. So you can specify the number of inputs and how you want it to multiply, and then you can connect the output to this. But what I would say is probably best practice in Simulink, if you know you're going to multiply it by a constant, in this case our spring constant or a damper constant, you want to use a gain. So a gain literally takes its input and multiplies it by the one parameter that it stores and then outputs that. So in this case, we are going to want to multiply it by K, our spring force, and we want another gain, and we want to multiply by our damping coefficient. So the other thing that we want to have to this is we want to put our input force. So if our input force is a constant, we can use this constant block. But if we were going to try doing some other things, we could add, we could use ramps, we could use pulses, anything that you want to make. The sources tab probably will allow you to make it. So what you want to do, you can right click on a signal to tee off of it. So if you right click on this, you can start dragging a signal off of it, and you might notice that Simulink does some weird stuff with routing when it gets confused like that. You can always clean that up later. So we take our velocity, we input it to our C gain, we take our displacement, we input it to our K gain. Yeah, that's beautiful. And then what we can also do is connect these to that. Another tip, if you're using a mouse, you can actually click in your scroll wheel to pan. If you're not using one, I have no idea what the command is, but honestly, Simulink is best used with a mouse. So these, and then this output is going to be M times A, and so we can put another gain that we can say is 1 over M, and you can, let me expand this a little bit. So Simulink will actually evaluate expressions that you put in here. So if you put 1 over M, it's going to divide by M. But if you wanted to multiply by, 5 plus 2 divided by x minus 4 or something, you could do that. It'll evaluate any valid MATLAB expression in this little properties thing. And so once we've done that, we have our acceleration. We can go and put that back in if Simulink wants to cooperate. Come on. There we go. Oh, well, we've got something hanging off, but we can just get rid of that. And now our displacement, the last thing we want to do is in the sinks, we could use a display, and what that's going to do is it will display the numerical value, or we can use a scope, which is used to display plots. So we can connect it to both, just so I can show you what it does. And then I'm going to maximize this window really quick. So there's a couple more things we need to do before we can actually run this. Go away. The last things we need to do is we need to specify how long we want this system to run for. So default is 10 seconds, but you can, if you type in INF, it'll run infinitely. That's a really great way to crash your computer if you have an error. Not your computer, it'll crash MATLAB occasionally. So unless you know it's not going to crash I wouldn't run something infinite the first time you run it. But we'll just do 20 seconds. And the last thing we need to do is actually go back into MATLAB. We need to, here, and I'll make this a constant. So when you type in just a letter or a name or something, what Simulink is going to do, it's going to look in the MATLAB workspace for this variable. So what that means we have to do is we have to go in here, we have to say that our spring constant is equal to 1. Our damping constant is 0.05, say. We need to define our mass, which, I don't know, 10 kilograms. And I haven't put units on these, but mass is going to be in kilograms. K and C are newtons per meter and newtons per meter per second, which are what would normally be used for it. And then finally, F in, I'm going to say, is 30 newtons. So now that I've defined these constants, this should run, but since I built it and didn't test beforehand, who knows? All right, cool. So it ran, and you can see that, maybe we didn't want to do that, but if we look at the scope, and I may have set the equation itself up wrong. All right, so something doesn't look right here because applying a constant force, we get this big ramp up. Oh, I know what it is. So, wait. Maybe not. Let me try something really quick. This is why I should always try and do this before I come do it for you guys. There we go. Sinusoid. Awesome. So if we go back into MATLAB and we increase our spring constant, what did I set it at? 1. Let's set it at 5. Go back in. A nice handy feature of newer versions is also from the scope window, you can hit run here. There. So now we've got we have a constant input, and since we really don't have much damping, you can see that we're just getting a sinusoid. So the error I had before, I forgot, you need to put a -1 here. A big thing to note is Simulink does not track units, so you are going, best practice would be to say that this, label this as force newtons, label this as velocity meter per second, and this as displacement meters. So the -1 here is because the acceleration is going to be in the opposite direction of your velocity and your displacement. So if you think about it, if I didn't have any force input and we started at a displacement of 2 meters, the spring is going to pull it back in a negative direction. So signs are also something you really got to keep track of. It doesn't know what equation you're trying to model, so it'll only do whatever you tell it to do. So then if we bump up our C gain, or our C turn a lot, let's bump that up to 2, run it, you can see that with a much higher damping rate, we can actually see the damping on this plot, which is very nice to see. So that is really the basics of how to go from an equation like this, of something that I think we've all dealt with before, to a Simulink model. Really simple, but always better to start simple and add complexity than try and go head on into complicated modeling. So with that, I'm going to go ahead and end the recording.